Dear students, good morning to everyone present here. In this video, we discuss about the basis of textile technology open elective subject. The first unit, basis of textile fibers and spinning. In this unit, we discuss what is meant by fiber and classifications of fiber and the properties of fiber and how the fiber behave in the properties. So first we see about the definition of textile fibers. Textile fiber is defined as a fine strand of tissues of plants or animal or any synthetic material drawn out into a very slender filament and subsequently cut into required length, and it is also defined as a continuous filament or discrete may elongated pieces. It may be made up of tissues of plants or animals having length 100 times more than its width and having commercial spinning value. Next we discuss about the classifications of fiber. In this classification we discuss natural fiber, man-made fiber. Natural fiber is classified into vegetable, animal, mineral fiber, and man-made fiber is classified into regenerated or man-made fiber, synthetic fiber or inorganic fiber. Synthetic fiber is also called as a organic fiber. So synthetic fibers again classified into uh, polyester, acrylic, nylon, polypropylene, polyvinyl acetate, polyvinyl chloride, polyvinyl uh, alcohol, polyethylene, polypropylene, and the natural fiber is classified into a seed fiber and leaf fiber and bast fiber, and animal fiber is classified into wool, silk and hair fiber. Mineral fiber is classified into asbestos. Regenerated fiber is classified into viscose, modal, copromonium rayon, viscose rayon and tensile. Next we see about the properties of fiber. In the first length to width ratio, the length of the cotton fiber is 1400 uh, and width is 1 mm. Next wool is 1000, 18,000, and flax is 170, silk is 33,000. Next we see about the images of jute, cotton, coir, hemp and flax fibers. Next, definition of stable fiber. What is meant by stable fiber? Stable fiber is definite in length, that is known as stable fiber, and filament is indefinite in length. Next we see the images of the stable fiber and filament fiber. Next we see about the essential properties of fiber: fiber length, fiber strength, fiber flexibility, fiber cohesiveness and fiber uniformity, bulkiness, flexibility. Other physical properties of fiber is physical safe, specific gravity, luster, moisture regain, content, elastic recovery, elongation, resilience. And some of the thermal and chemical properties of fiber: resistance to thermal behavior and resistance to moth, bacteria and fungi, and resistance to chemical, acid, solvent and alkali, etc., and resistance to biological agents, resistance to sunlight and resistance to environmental condition. Next we see about the strength. What is meant by strength? It is also called as a tenacity. Tenacity is the defined as according to ASTM, American Society of Textile Manufacture, the tensile strength when expressed as a force per unit linear density is called as a tenacity. Tenacity is equal to breaking load divided by mass per unit length. And also strength is also defined as breaking strength determined by breaking strength, that is tenacity strength, which is expressed force per unit cross sectional area. Next we discuss about the some of the tenacity of the natural and man-made fibers. Polyester is having very high tenacity in man-made fiber. In natural fiber, hemp and ramie have a very high tenacity. Next we see about the flexibility. Flexibility is very important property. The fiber have sufficient by pliable. Only it can be wrapped around another fiber during spinning. Many substances in natural resemble fibers form, but they are not practical fibers as they are stiff and brittle. Next we discuss about the cohesiveness. It may be also termed as a spinning quality of fiber. It is the property of an individual fiber by virtue of which the fiber hold on to one another when the fiber are spun into yarn. Next, uniformity. It is the defined as the length of the fiber which was spun into yarn to make good quality of yarn. It is the important fibers must have similar in length and width in spinning quality and in flexibility. Next we see about the physical safe and um, specific gravity. Physical safe is the safe of the fiber has good impact on the other properties of fiber. It affects the surface irregularity and cross section of the fiber. Next, physical specific gravity. Specific gravity of fiber indicate the density of the fiber. That of the water is 4 degrees centigrade. We know that the specific gravity of water is 4 degree temperature as per 1 per cubic centimeter or pounds per cubic unit. Density indicate the mass per unit volume and expressed in gram per cubic centimeter. Next, so we see about some of this density of natural and cotton fiber. Cotton 1.54 to 1.56 and Rami 1.51 and hemp 1.48 etc. Next we see the luster. Luster is very important property to one fiber. The luster will help to absorb the fiber water absorption of the fiber, and also it gives the brightness to the fiber. Next, moisture regain and moisture content. A moisture regain is defined as the amount of water as an internal part of the structure. This is because of the humidity present in the nature or atmosphere. Fibers with good moisture regain and moisture content will accept the dyes and chemicals more readily. Next we see about the absolute humidity. It is the weight of water present in the unit volume of moist air. It is the actual density of water vapor in the atmosphere, and it can be expressed as in terms of gram per cubic foot or gram per cubic centimeter. Next we see the relative humidity. What is meant by relative humidity? It is the ratio between the actual vapor pressure to the saturated vapor pressure and is expressed in as percentage. Next, we see about some of the uh, relative humidity at 65 percentage and temperature, room temperature 25 to 30 degrees centigrade. How the moisture regain of cotton, mercerized cotton, silk, wool, acetate, viscose rayon. It will be for raw cotton. It will be 8.5 to 15 percentage. Mercerized cotton 10.3 percentage. Silk 25 percentage. Wool 29 percentage. In the conclusion, we see wool has very high moisture absorption property. Next we see about the elongation. It is very important property in order to stretching or extension of the fiber. It is measured either elongation at the center load or elongation reached when the fiber breaks. Elongation is expressed in as percentage. And we see about the elongation or elastic recovery value of some of the natural and man-made fibers. Cotton 10 percentage, hemp 1.8, wool 40 percentage. Next, resilience, thermal behavior. Resistance to biological agents is very important. Resistance to chemical is very important in order to dye the fibers, and resistance to environmental condition is also very important. U sunlight, UV rays, rainfall. So the fibers can withstand these natural disasters, etc. Next, we see about the what are the basic requirements for fiber forming polymers. A more parallel or less parallel arrangement of molecules, lateral forces to hold the molecules together and give cohesion to the structure, and long chain molecule corresponding to the long fiber that make up yarn. If the molecules or fibers are too short, there will be a loss of strength as illustrated in the diagram. Some measure of freedom of molecules movement in order to give necessary extensibility to the fiber, and some openness to give room for moisture absorption and uptake of dyes. Next, we see about the images of requirement for fiber forming polymers. Next, we see about the some of the important properties, that is the fiber length, fiber fineness, and fiber strength, and elongation, and cleanness, and stiffness, and chemical deposit. These already we discussed in the previous slide. In this slide we give some of the values about the fiber strength, length, and also micronear fiber fineness. Micronear value very fine, 3 is very fine, and 3.1 to 4 is fine, and 4 to 4.9 is medium, 5 to 5.5 is coarse. And fiber maturity coefficient 20 is 0.80, and 40 is 0.85, 8 is 0.95, hundreds and above 0.95. Maturity refers the number of matured fibers in the cross section of the yarn. Next, we see about the strength. 20 is 13.5, 40 is 16.2, 80 is 22 gram per text, hundreds and about 27. Next, stiffness, cleanness. Cleanness means non-vegetable matters or cloth fragments, packing materials, metal fragments are present on the surface of the fiber. Fiber stiffness, it is very important property. A stiffer fiber cannot bind properly. Fibers should be flexible for effective binding, uniformity, and strength of the yarn. Next, we see about the sequence of machineries for corded yarn manufacturing process. Before seeing the sequence, we must know about the fiber properties and definition of fibers and classifications of fibers. For that purpose, we see the basic requirements. So, the modern corded yarn manufacturing process, these are the process sequence we implemented in the latest spinning mills: mixing, blow room, carding, breaker drop frame, finisher drop frame, simplex, ring frame, and winding, cone winding or doubler winding, and heat setting, packing. Next, we see about the flow chart for combed yarn process: input, fiber, bale, lap, and corded slaver, and pre-drawing slaver. Next, we see about the lap, combing slaver, draw comb slaver, roving, and yarn. This is the sequence for combed yarn systems. Next, we see about the yarn numbering system. Yarn numbering system is very important for the textile technologist. According to the Textile Institute, count is the number indicating the mass per unit length or length per unit mass of yarn. Count is defined as the numerical expressions or fineness of the or thickness of the yarn. Before going to the yarn numbering system, we must know what is the classifications of yarn numbering system: direct system and indirect system. In indirect system, English system, French, metric, and worsted count. In the direct system is classified into tex and denier. Tex is defined as weight in grams per 1000 meter of length. It is a universal system of counting of yarn. Denier is defined as the grams, weight in grams present in 9000 meters of length of yarn. It is basically used for man-made fibers. Next, indirect system is, first we see about the English count. Number of hands of 840 yards present in 1 lb of yarn. Count formula is length in yards divided by weight in pounds into 840. Next, metric is defined as number of hands present in 1000 meters of present in 1 kg of yarn. Worsted is number of hands 560 yards present in 1 lb of yarn. It is basically used for wool. Next, we use the count conversion. Conversion is from text to denier and denier to text. We use the constant data. Count is equal to 590.5 divided by 6. It is convert the text to count. Next, we convert text to count 590.5 divided by count. Next we convert the factor count into linear or linear into count. For count into linear, 5315 divided by linear, and linear to count is count 5315 divided by count. Next, these are the basic requirements for length and weight measurements. Without knowing these basic definitions, we cannot read these topics. Before going to this topic, yarn properties, we must know about the yarn numbering system. Then only we can know the yarn properties. In yarn properties,